Hi, my name is Joshua Galvez, and I'm a math teacher in California. And I have something to rant about. So, math education in the United States, at least from what I've seen in the area that I am and with the teachers that I've seen, is not the best. And that's not to say that we don't work hard. Um, it's not that we don't work hard, and it's not that we don't have some idea of where to go, but there's a lot of issues why it's just bad. Um, so I'm going to talk about a few of them, um, but it's a really in-depth issue, and there's a lot of studies on it and stuff. But let me just rant for a sec. So math is not relatable to students. I mean, you think about the math classes that you were in, and they haven't changed that much. Even with the Common Core standards and stuff, math is still the way that it's being taught is still the same. The content that is being taught is still the same. And students can't relate to it. If you can get students to buy into it, to that sort of abstract thinking, that sort of like, you're never going to use this, but it's fun to learn anyway. If you can get that, I think that's kind of a key. You can really get students to learn. But that buy-in is so difficult, especially when you have students like we have here, where they don't see the point. They have a filter of what is useful to them, and anything that's not useful to them, they just tune out. So they will tune in to their math class as much as it's useful to them, and that usually is no more than their grade. It's as useful to them as their grade is to them. So you get students that they're happy with a D. They're like, well, a D is all I need to graduate, so I'm gonna be fine, right? Or they're happy with a C or whatever. And it's just it's such a small percentage of the population that actually cares about using it. I mean, you talk about people that actually solve equations and that actually manipulate variables, and it's a very small percentage. You've got scientists, engineers, computer programmers, and mathematicians, and that's it, right? And those people are using math. They're using the math they learned in high school, but they're using it in a very creative way, and it's in a completely different way than the way that we teach it. So there's this big disconnect. The students, the majority of them, don't want to go into the STEM fields. They want to, be hairdressers, or go into beauty, or go into sports, or they know they're going to be teachers, or they're going to be policemen, or whatever that you think that you're going to be, or office workers, and they don't see the need for math. And especially they don't see the need for the math that we teach, the way that we teach it, which I don't blame them for, because the reality is that they don't need this kind of math. Are they ever going to need to solve a quadratic equation? Probably not. Are they ever going to need to know, what a polynomial is? Probably not. Are they ever going to have to really graph anything? When was the last time you graphed something? So probably not. It's a very small percentage of the population. So I actually think, and I've been saying this for a while, I actually think that math, the way that it is currently taught, is actually an elective. It is a forced elective, and it's an elective in the sense that it's in the same tier So in high school, when you choose an elective, it's because it's something that is specialized, right? You want to go into that. So you choose biology over chemistry, or you choose chemistry over physics or whatever, right? But you kind of have this choice between those, and it's kind of you choose how you want to specialize. So math is a niche, it is a specialization, and it's being treated as something that all students need. And all students do need math, but the type of math they need is not the type of math that's being taught. The type of math that's being taught is that specialized. It should be an elective. Students should be able to choose, I want to specialize into this very abstract kind of math. I don't know what else to say. There's so much to say that I don't know what else to say. The math that needs to be taught should be a language. The way that it needs to be taught is as an access to actual things in the real world. And so that when students read something that has math in it, they can understand it. As much as there is math in the real world. So there's a lot of math studies out there that say that we should be focusing more on probability and statistics, and I tend to agree with that, because students are going to that's the kind of math that students are going to be exposed to in the real world. When you talk about elections, when you talk about people skewing data and bias, and when you talk about like tribalism and all this kind of like propaganda, all this kind of stuff, that's where statistics and probability come into play. And that's probably the most relevant to our kids, and that's not an essential target. That is not an essential standard. Because math teachers are more concerned about, I need to prepare students for the next math class. I've heard that. I've heard math builds on itself, and if they miss something, then that's something they're never going to get. They're going to be behind. So that part is true. They will be behind, but only in that specialized math, that sort of elective style, very STEM type math. What we need is a math class for the general population. We need a math class that people can go into this class and you can immediately see the use for this. You say, I know why I'm here. And it's not because the teacher told you why you're here. It's because you can see for yourself that it's useful. And so I think math education needs to take a long look at itself, and it needs to have a massive change, like a huge change. So another thing that kind of ties into this is the increasing amount of technology available to everybody, students, but also everybody. A long time ago, when math was originally decided, like everybody needs to learn math, everybody needs to learn algebra. A lot of time was spent, a lot of class time, instruction time was spent just teaching people how to do the calculations, teaching people how things got manipulated in order to get an answer. And that mentality is still with us, and it's poisoning math. Students come in, and teachers too, because I think most of us don't know any better. Right? We teach the way we were taught, and so we're kind of stuck in this. But students come in and they expect that a math problem has an answer, and they expect that answer to be already, it's going to be easily worked out, easily meaning within the appropriate amount of time in a class. And the teachers teach it that way too. And the purpose of math is to get an answer. That's the mentality. And that's not really the case. And it's definitely not the case that that is useful. So the technology that students have now further just demotivates, because why do you need to know how to solve a quadratic equation by hand when you've got different apps and websites? You've got Photomath, you've got CY Math, you've got Wolfram, you've got Symbolab, right? All these different things that can solve these equations for you. So what's the point of being able to solve them? Now, there is a point, if you're talking about that STEM, that kind of very specialized math, you have to know how all of it works, because you're going to be working with it creatively. But in the real world, quote unquote, the real world, you know, when you're an adult and you're working just a 9-to-5 job in some office somewhere, or, you know, whatever, you don't need to know how to solve quadratic equations. And if someone comes up to you and says, you know, solve this, you just pull out your phone and take a picture and it solves it for you. So it's like, what is the point of math? What is the point of the math that we're teaching? So the math that we need to be teaching to everybody is actually more of an interpretation. It's a language. We need to teach kids how to speak in math, how to read in math. We need to teach kids, you know, how to get meaning out of mathematical works, or at least how to find not necessarily mathematical works in the sense of like a math textbook. I mean, someone posts a new study, right? And they're claiming that, you know, this vaccine is gonna cure this disease. And they post all this information. And then person says, oh, well, you know, that vaccine is going to have these side effects. Well, a mathematician, someone who actually, I would say a fluent mathematician, would be able to look at all the data and be able to understand and make an informed decision. So, you know, there is a 0.01% chance that this vaccine is going to have a negative side effect, but there is a 10% chance that if you don't take the vaccine, that you're going to have this crippling disease. You know, so then you can make a judgment call. If students don't know that kind of math, if students are not able to interpret situations mathematically, then you get propaganda, you get people jumping on a bandwagon, you get this emotional discourse that people just say, well, I feel this is right, I feel this, and everything comes down to feelings and nothing comes down to facts. And that could be a commentary on our current social situation. Anyway, I could say a lot more, but let me know if you want me to talk more about this, or to explain any more about any of these specific topics. I know this was kind of overarching. And yeah, leave a comment or leave a like or even a dislike. Yeah.